Hey, welcome back, you guys. So this is December 3rd and CSE 101. So one thing I want to go ahead and get right into, because what the plan for today is we are going to introduce arrays. We will not complete them. In fact, arrays have, I think, 3 weeks dedicated to them. So we will introduce arrays today. We will look at a couple of examples, but then what I'll do is I'll leave the last bit of time for today's lecture for us to do a review for the exam that is coming up next week. Okay, uh, so just all right. So yeah, so we'll do that exam review. So speaking of graded quiz exam type stuff, let me share this. Because a few of you, as I kind of expected, a few of you, quite a few of you, have messaged me concerning the quiz, concerning this assignment quiz with some questions, and they kind of fall into some particular categories. So I want to address some of those just with everyone here now, so that you don't have to individually email me. Okay, so a few of you wrote in response to this one that you had given the answer as 2, 5, because in outside of America and outside of certain other places, the comma is the decimal point, whereas the dot is the thousands place marker. And you asked if I would be giving the points for that. Yes, I will, because that's just, you understood what the question was asking, and you showed that the question, that the answer should be 2.5, 2.5. So yeah, you'll get points for that. Some of you asked, you did F, D, and then a plus sign 3.5. I'm not going to be able to give the points back for that. The point of this question was to find out, did you understand what this plus sign meant? Did you understand that this plus sign doesn't get added as part of this, that this becomes a string, so this plus becomes string concatenation, which puts this and tacks this onto the end. The plus is not, so what I asked was, what was the value assigned to my val? And so I cannot give the points for if you included the plus sign in your answer. It would be like if I asked, what is 3 plus 2, or here, what is 3 plus 2, and you said, well, 3 plus 2 is 3 plus 2. Well, no, I need to know that you know that that means 5, right? So in a math class, you would not get points for a numerical answer in a math class if you didn't give the accurate value, if you just said, oh, this is 3 plus 2. So, okay. Let's see. One other question that some of you guys have been asking is, you got really low scores and you're very concerned about that. Again, so pretty much these last, anything beyond these, right, these first 6 questions, the last 4, I have to grade those. We cannot, and I've said this before with the last quiz, I cannot auto grade an answer where I ask you to explain something. So this is, what is that, 30, 40, 55 points from this quiz is going to be me having to grade it. So the fact that you may have gotten a lower score than you expected is because these questions have not been graded at this point. Okay, all right. So looks like there's a question somewhere. Okay, Emre, right, but you gave the final answer. So I will give points for something like that. If you explain that 0.5 plus 2.0 equals 2.5, and you have that you understand that the final value is 2.5, yes, I will give points for that, absolutely. But if you in this one said, well, it's just FD plus 3.5, and you don't understand that the plus sign means string concatenation, so it becomes one whole string value. Okay, this is some key stuff that I'm going to talk about during the exam review time is that you have to know that this plus sign is concatenation when a string is involved. You have to know that it puts this, it converts this to a string value and then puts it at the end of that with no space between them. Okay. What else? String concatenation. We will also, there was another one in that I can't remember what I was thinking of. We'll go over that during the exam review. I'm sure it'll come to me before we get to that point. Okay, so if someone had put FD plus 3.5 equals FD 3.5, that would have been the same thing. It's like the final value is FD 3.5. Okay. All right. So let's get back to not sharing that, and instead we'll go ahead and move on into arrays. There are some others of you who have asked individual questions for yourself that I will respond to those hopefully today. But those, I just want to catch this because that was quite a few of you had asked those particular questions, and I want to make sure that we cover that we talk that through. All right. Let's see. Let me. Okay. Well. Okay. So in honor of that you have an exam coming up, quote of the day today comes from Tom Bodett. In school, you're taught a lesson and then given a test, but in life, you're given a test that teaches you a lesson. So it's sometimes also phrased as life gives the test first and the lesson second. So thought just it's an interesting take on things that hopefully you guys do not make too many life mistakes that have to teach you hard lessons. Right? Hopefully you can learn from other people. I actually should have shared this. Yeah. So don't want to spend too much time on that. I just thought it was an interesting quote that you guys might like. All right. So let's talk about arrays. All right, so let's say that our problem was we wanted to get 100 numbers from a user. We want to read 100 numbers from a user. So far, you can do that. Nothing is given. Nothing that in that is something you can't do. You know how to do that. You know how to use a loop. You know how to use scanner. You're good. Compute their average. Hopefully you know how to do that as well. You could add up all the numbers that the user enters and then get a total, and once you end the loop, you divide that total by 100. That's their average. All right, so far so good. And find out how many numbers are above the average. Oh, well, that's a problem, right? Because what if you might think, okay, well, what we can do is we can keep a running average, right? So let's see, let me insert a table. Okay. And okay, so let's say that we're gonna start out with the number of numbers above average is 0. We don't have any yet. And we'll say, okay, the user says, all right, they enter a 1. Well, what's the average of the numbers so far? 1. Okay, how many are above average? Still none, because 1 is not above 1. All right, fine. All right, now we enter 2. Okay, what's the average? 1.5. Okay. How many are above average? Oh, we have one that's above. Is value above average? Sure, we'll make that. So now there's 1 above average. Now they enter 3. What's the average? 2. And we could say, okay, is that above the average? Yeah, okay, now add 1 to it. Oh, except, wait a second. Now we have a problem, don't we?
Var da TR'de aldırayım o zaman. TR'de. TR'de canım ya.
All right, so here's a problem right now, because now we have two. We say that they're two above average, but that's not right. Right? The problem was that when we moved on, if we have just a single variable value, when we get a new value from a user, we lose the old one. We don't keep track of it. So like even if they were to say, okay, well, we'll do 100. Okay. And we'll say, what's the average of, let's do a number that's divisible by 4. So let's say 102. Okay. So now 102 plus 6 is 108, which divided by 4 is, what's 102 divided by 4? 108 divided by 4. 27? 27, I think. Yep, good job. All right, thanks. Ron, you're faster than me. Okay, so 27, right? So, and we asked the question again, okay, is this above average? Yes. So we add one to above again. Now we're really off, right? Because now we really only have one number that they entered that's above average, but we're saying there's 3. So this is really, really bad, right? We can't do it this way at all, right? And the reason why is because as we enter new values, if we just have one variable that stores the value, we lose all the old ones, right? This especially would get really problematic if we entered, if we started really high. This could also be the other way if we started really high. So if we did, let's say we did 100, let's say we did 10, right? And the average is 10, so there's none that are above average. And then we said, okay, now we're going to go down and we're going to go 8. Okay, and now the average is 10 plus 8 is 18 divided by 9. 10 divided by 2 is 9, right? So now 8 is not above average. We still have none, but we did have one that was above average, right? Yeah. So we can't do it this way. This is not going to work. We need some way that we can enter new values but keep track of the old ones. Okay, and this is where we get into with arrays. Okay, so this is where arrays are going to come into play. And so the idea is that an array is simply a list, like a grouping of same types of data. Okay. Now, what happens here is you have a memory space like a variable that stores a value, and then it just basically says, okay, now this whole next n number of data spaces will all store the same type of value. Okay. All right. So that's how this is going to work for arrays. So we can just basically treat each one as an individual variable. Now, the way that this works is very similar to a variable declaration. Okay? But one big difference is that instead of just being a single value in here, it's going to store a kind of pointer to a set of memory locations that will store the same types of data. So, all right. So here, all right, the way that we declare this is we have a data type, but now we need the brackets. Okay. So the brackets tell me that this variable is going to be an array, not just a single of that type. Okay. So you could say double brackets my list creates a pointer to an array in memory that is of type double. So everything inside of that array is going to have to be a double value. Okay. There is another way that we can declare arrays. We can put the brackets after the variable name. It's allowed. The compiler will be fine with that. It's generally not preferred. The reason being that this tells me that this tells me the type and this tells me the name. Okay, it's a little bit clearer to help us understand that this name represents a type, and then that type is an array. Okay, all right. Now, when we create the array, we have to give it a size. Okay. An arrays in Java are required to have a size. So those, if anyone has any Python experience, or there's a couple other languages that do this, those Python uses what's called a list, where it doesn't have to be declared of a specific size. Unfortunately, Java does. So we have to say, okay, this is a particular size, and this means I want you to create this many. The special word for this is contiguous, meaning connected, meaning one after the other. Okay, this many data locations of this type. Okay, so this creates a set of 10 data locations of type double, and then assigns that to my list. So now my list at index 0 references the first element in the array. So just like strings, we talked about char at, character at 0 is the first character in a string. An array is 0 indexed as well. So that means 0 references the first, 1 represents the second, 2 the third, and so forth. All right, so in a 10 element array, 9 would be the last element. Okay. And we'll talk about, I'll just tell you right now, if you were to try to index with something higher than that value, so if you were to try to index with my list of, okay, my list of 10, for example, this would give you a runtime error, because it would say index out of bounds. Some of you probably have gotten that with the string. We actually looked at an example where I got that with the string when we were doing, I think, the palindrome example last week. So it's the same thing. It's an index out of bounds exception. Okay. All right. You can, just like with variables where you declare and assign in the same step, you can declare and create an array in one step. So you have double array my list equals new double 10. So this creates the array, assigns it to this variable, all in one step. Okay. And just like I said before, you can do it in this format, though it is generally not preferred. It's generally frowned upon to declare the array this way. Okay. All right. One aspect of Java being that you declare an array of a certain size, right? You have to give it a size of the array, is we know what the length of it is, right? Once the array is created, its size, we know what it is, it can't be changed, and you use the length parameter, the length attribute of an array to find out how many values, how many locations there are in there. Now that doesn't mean that we've given values to each of those. We'll talk about what default values are in the very next slide. But what it means is this is not how many values I've put into my array. This is how many possible values my array can hold. Okay. One big thing I want to make sure you see here is notice that for an array, length is an attribute. Okay. For string, like if I had my string and I wanted to find out what the length of it was, that is a method. All right, so it needs the parentheses. So string needs the parentheses, array needs the attribute. Okay, make sure you know the difference. This makes for a pretty easy. It makes for pretty easy to make up exam questions. So for like next week. Okay, so make sure that you understand the difference between a string length method, an array length attribute. All right. So I said we would talk about default values. Here we are. When an array is created, the elements, it takes all these data spots, right? And it has to put some value in there. It can't just put nothing in there. It has to hold some type of value. So default values are 0 for the primitive numeric data types. Okay. 0 for numeric primitive data types. So like integers get 0, doubles get 0.0. Okay. For character types, it is what's called the null pointer character. It's basically kind of meaningless, but it's not a printable character. It's used to terminate a string in old C days. But basically, it is the, like I said, the null pointer character. In ASCII, this is 0. So remember, char is kind of actually it's really an integer data type, an integer-based data type. So this is basically integer 0 for character types, right, for ASCII. Right? And then finally, if you have a Boolean array, it'll put it as false. Okay, all the Boolean values will be false when the array is initially created. Okay. All right. Looks like I have a couple of comments. Let me check those before I move on. Okay. Actually, the base data structure for an array list is an array, and we'll talk about that when we get into array lists. But you're right. An array list is very similar to an array with just some neat, fancy stuff it allows. All right. Okay. Moving on back. All right. So, like I said, the arrays in Java are what's called zero indexed. It can get a little bit confusing because when we say the first value in the array is index 0, and I want you to find me the third value in the array, and so that's actually index 2, it can get a little bit confusing. But there's reasons for why they do it this way. That involves efficiency and some other reasons. So just make sure you know that in Java, if you want the last value in the array, you can get that by finding out the array length and then subtracting 1. Okay. If you try to access an array using the array length itself, you will get an error. If you try anything above the array length, you will get an error. If you try anything below 0, so if you try to get a -1, for example, you will get an error. Okay. So what we do is we index an array, we give it the array name, open bracket, whatever index, which needs to be an integer, type, and we can put in a variable in there, as we'll see in some examples when we loop through an array. So if we go back to the very first question on this set of slides about taking in 100 numbers from a user and adding them up, finding the average, and finding out how many numbers are above there, we'll loop through using an iterator, using I from 0 to 99. And we'll use I as the index of that array. Okay, so we can put a variable in here as long as it's an integer data type and to access the array. So we can use an indexed value in the array the same way we would use a variable. So if we see this as this is just 3 separate variables. They just all happen to be the same data type, and they all happen to share some memory locations. And in real programming, like when you write a program, they're probably going to have some relationship that makes sense to the programmer and the user. But as far as the compiler is concerned, and as far as the execution of the program is concerned, this is just seen as 3 separate variables. And so what's happening is we take the value of the first variable, we add it to the value of the second variable, and the total we assign into the place of the third variable. Okay, so the first place in the array, we add it to the second place in the array, and we put that into the third position in the array. Okay? So we can use it to get, just like with a variable, we can use it to get a value, we can use it to assign the value. These are just containers. So it's like if I had 3 cups, right? And I took the contents from one cup and I added it to the contents of another cup, and I put the sum, the container, the two together into the third cup. All right. There is another way that we can initialize an array. Now, the way that we did this, let's see, the way that we did this back here, right? This gave us, sorry, let me look at this one because this is the one that we want you to use more. This one, you should know based on what we've talked about so far that this created an array of 10 double locations and all their values were 0. Right? All the initial values were 0. Right? They didn't have any other value to start with. Okay? This is one way that we can declare basically an empty array, an array of default values. But what if we want to start with some values in the array already? Right? We don't want to have to go and put these values in one by one. We want to be able to start with an array of values already there. So this is a way we can do that. Now, this can only be done in this initialization. Okay, we cannot. We'll see in a moment. There's other ways we might want to try to use this, but it won't be allowed. Okay? So if we look at it like this, okay, all right. So if we were to do this here, this would be the same as if we had created a double array of 4 positions and then one by one put those values in, right? This is much easier, right? If we have a specific set of known values to start with, this is much easier. If we have values we're trying to get from the user, then this is, we want to do it this way, one by one. Okay. Especially if we need to check each value and find out something based on it, okay? All right, let's see. Now, some caution, okay? This could create a syntax error, a compiler error. This may be based on older Java. I need to take a look and make sure. I'll do this during the break. I think some versions allow for this, but just in case, don't do things this way because this would cause a syntax error. Okay. All right, let's trace through a program involving an array, and then we'll actually take the break early today because so what I'm going to do is instead of 3 almost hour-long segments, we're going to do 3 shorter segments today and end quite a bit early today. All right. Okay, because I want to give you time to study for the exam and get an idea of what the exam is expecting. All right. So here we take an array of integers and we say, okay, I want to create an array of integers of 5 positions, and I want to assign it to this variable called values. So what happens? We have this array of 5 positions. They all have zeros in there. Notice these values on the left are the index of the array. So 0 is that first position, 4 is the last position. So this line creates the array, assigns it to values. Okay. Now, we say, okay, I becomes 1. So that's just a variable, I is 1. And the reason why we're starting at 1, you'll see why in just a moment. Because what we want to do is we basically want to add each value to the one before it, kind of thing. Right. So I is less than 5, good, right? Yep, 1 is less than 5. So now what we do here is we say, okay, we're going to take the value from I minus 1 position, 0. So the values at the first position, We're going to add it to I itself. So 1 plus 0 is 1. And we're going to assign it to the index at position 1. Okay, so 1 plus 0 equals 1. We assign that to position 1. Pretty straightforward so far, right? Okay. Then we'll do I plus plus. I becomes 2. It's still less than 5. So now we do something again. Now, here, we take this. I is 2. So the value at position 1, 1, plus I, 2. So 2 plus 1 equals 3, and we assign that to index 2. That's how we get this over here. Okay. I becomes 3. I is less than 5. So now what's going to happen? When I look at the next slide, what's going to be the value assigned to what index? I is 3. To what index? So the value is 6, and what index is it going to? All of you getting the value 6. All right. Yep. Right. So 6 is going to be assigned to position to that index 3, the 4th value. Okay. Good. Okay. So keep going. I is 4. I is less than 5. So now in position index 4, we're going to give 4 plus 6, 10, and put that into there. Okay. So now I becomes 5. This is now false. So we're going to exit the loop, and then we're going to take the thing in position 1. We're going to take the thing in position 1, which is 1. We're going to add it to what's in position 4, 10. So 1 plus 10 is 11, and we will put it into position 0, into index 0, which is 11. Okay? All right. So we processed through that. And so some of the things that we can do by processing through arrays, there's some examples, and I'll save this for after the break because we won't get through all this next set of examples before the break is over. Okay, so but these are some of the things that we can do of how we can process through arrays. If there are any questions, let me see if there's any questions. Look back through all the 6s and stuff that you guys wrote. Doesn't look like. Okay, so what we'll do is, like I said, we'll take the break quite a bit early now. But we'll still meet up again here in 10 minutes, and we'll continue on. So at my clock says 10:07 now, so at 10:17, we will start up the next part, the next section of this second part. All right. See you guys in 10 minutes.